Hi, welcome back. We're looking at the core Agile practices from the Agile Practice Guide from Project Management Institute and the Agile Alliance. This one in particular is continuous integration and other execution practices. As we've seen in Agile is the combination of an iterative approach where we're iterating and improving on our product, and also an incremental approach where we're delivering something usually at the end of those iterations. So we're delivering something that a customer can see, feel and touch, and just to check whether we're on the right track or not, that the requirements are being met. So delivery of a product increment or a feature that is usable requires reliable, working and integrated software at the end of each of these sprints of between 2 to 4 weeks, usually closer to 2 weeks. Continuous integration addresses this challenge by merging all of the changes made to the software and integrating all change components regularly at least once a day. That means configuration management, compilation, software build, deployment, and testing are all wrapped into a single automated and repeatable process. And since developers integrate their work constantly and build constantly and test constantly, then defects in the code are detected much more quickly. And that's the real key. We're gaining that feedback on whether everything is working in the way that we want it to be working by integrating all of the different changes that we've made and putting them into the one test, usually a test environment or the one working environment, and then running an automated test just to see if everything, if nothing has broken by combining all of these changes. And by doing it daily, we're getting fast feedback on a really regular basis. So by the time the end of the sprint or the iteration rolls around, then we've been doing this every day, so we really know if something is not going to be working for the end of that sprint. Now there are other execution practices as well. First of all, we've got testing at all levels, which is where we apply end-to-end testing and unit testing. So unit testing is testing an individual story or feature. So that's a small piece. You develop the code and then you just unit test that particular feature. But end-to-end is where we have many different features, and we want to make sure that the overall result is tested, usually by one of the users as well. In an Agile team, we have a preference for automated tests. So can we automate those unit tests using Selenium or in the code itself? Or can we automate those regression tests and run them daily as part of our continuous integration when we're putting all of our changes up into the one environment? We also have acceptance test-driven development, which is where we're creating end-to-end user acceptance tests by feature as a team. So that means everyone gets together and so we've got the business owner, for example. This is the whole team approach. We've got the business owner, we've got the developer, we've got the tester, and they all have an input into the acceptance criteria so that we know what the definition of done for that particular feature is. So then we're creating these reusable regression tests. Once that goes in at the end of the sprint or the end of the iteration, then we can reuse those tests and make sure that nothing is broken in the future as well. We've also got test-driven development, which is TDD, and behavior-driven development, which is BDD. Behavior-driven development is your given, when, then scenarios. So this is usually part of the automated test framework, such as Cucumber, when you're doing automated tests. But basically, given a certain scenario, when this happens, then I want that to happen. And that's just a way of writing that test from a business or a customer point of view so that you're really clear on that acceptance criteria. Test-driven development is where we write the test first. So we write the test first, then we write the code, and then ultimately the test should pass after that. So first we test, obviously the test should fail because there's no code to support it. Then we actually write the code to do what we want it to do, and then when we test again, it should pass. That's test-driven development. Lastly, we have spikes as well. So spikes are time-boxed researches or experiments. This is where we need to maybe estimate more on a card, figure out the acceptance criteria definition, learning some critical technical information or functional element. So really doing that research where maybe just the normal workday is not enough. We need to really set aside some time, gather the resources, and delve into a problem and problem solve. and that's where a spike comes in. And that is continuous integration and other execution practices.